Hi, so this discussion is on quantile regression. So, what is quantile regression? It means that I have multiple lines based on the data, the value of the data. So, instead of I use one line to represent it. So, can this improve the results? Yes, usually you can improve the results. Say, for example, you have these results. There's the household income versus the food expenditure. So you can see the data on the lower end, the line could be less steeper than on the higher end. So you actually can use several lines to represent the quantile regression. So this is the normal regression. So normal regression, one line. But look at all this data, actually the below one can be covered by another line less steeper with a lower gradient and the others with a higher gradient. So this is some error plotting. So the question is, can we do that? The answer is yes, we should use multiple lines to look at the this quantile regression. So we look at the lower income family, the average income family, and the higher income family. Okay. So this is the income. So the lower range, the middle range, and the higher range. Okay. So we should have multiple lines for that. So for example, maybe three lines. So if you look at it, the quantile, we actually can have. So what we can have in this the parameter that control, we call it tau. Okay. So if you look at this, tau equal to zero point 0.5, and we can have another line. Okay. So this is the we can have multiple lines with multiple tau value, and we can look at whether is it significant at the end. Okay. So like for example, we can have one line, two lines, three lines, so quite a lot of lines. Okay. So the tau we can have 0.05, 0.1. This is the percentile. 0.75, 0.9, 0.95. So which one are we looking at? Okay. So this is the tau and this is the slope. Eventually, this is what we have. Okay. Then after that, I'm going through the Python. Exactly the same thing you can do for Python as well with the different tau. Okay. So let's look at the R first. So for the quantile regression, which can improve the results of this regression with a multiple line. So quantile regression, so this is a food expenditure quantile. So this one, let's see. So the data is on the income versus the food. So this is the one. We have 235. So income versus the food. So by right, the higher the income, the more expensive you buy. But the problem is at the higher income, you may want to go to fine dining, etc. There's even steeper, right? So this is the normal regression that we're going to use. So this is the simplest one. So this is the typical normal regression. So you can see that three star means that the income is actually quite related to the purchasing of food, quite obvious, right? So the quantile regression, then we can have the tau, so 0.5, the 50 percentile. And then after that, we can have more tau. We can have 0.05, 0.1, 0.25, 0.75, 0.9, and 0.95. So then we can look at even more of this. So if you look at the table, and so this is the one, eventually we have six lines here. So this is all the six different lines, and this is the R part of this uh, quantile regression. So we can do the same for on a mirror Python. So Python and R today are the top two model, and this Python similar to the our program that you can run the Quantile as well. So just to set the environment first, to set the interpreter. So check the interpreter. So okay, and okay. So this is to set the interpreter for this quantile regression. Then we can start to run the quantile regression. So run the quantile regression. Okay. So this quantile regression. So same thing. This is uh, we call it quantile regression. So you can see the line, different lines on that, and this, if you look at this quantile regression, so these are all the parameter, and this is the model, and eventually we are looking at the plotting of all the data, all the few lines there. So so far this is the uh, typical quantile regression programming, and thank you for listening. And this quantile should be a small improvement from the normal regression with a single line, especially when the data is uneven at certain range of data.